Tonight, we're going to talk about the universe, something you've seen your entire life, something you've heard described countless times, and something your intuition insists it already understands. You've heard this before. It sounds simple. The universe is big, space is vast, things are far away. But here's what most people don't realize: the way your mind imagines the size of the universe is not just incomplete, it is structurally incapable of being correct. Not because you haven't learned enough facts, but because the scale itself does not fit inside human intuition. We are going to begin with something familiar: distance, not as a number, but as experience. The distance you walk in a day, the distance a car travels in an hour, the distance a signal takes to cross a room. Now stretch that distance until it stops feeling stretchable, until it stops feeling like distance at all, and starts feeling like waiting. Waiting that cannot be hurried, waiting that cannot be crossed by effort, waiting that does not care how advanced you are. Like the fastest thing we know moves so quickly that, in everyday life, it feels instant. Flip a switch, the room is lit. But even light needs time, a small amount of time, then more time, then so much time that distance turns into delay. Delay turns into separation, and separation becomes a permanent feature of reality rather than an obstacle to overcome. By the end of this documentary, we will understand why words like far, large, and ancient quietly fail when applied to the universe. We will understand why familiar units, meters, seconds, years collapse under extreme scale. And we will understand what replaces them, not as facts to remember, but as a new intuitive frame that can remain stable when numbers stop being meaningful. If you want to stay with this to the end, the only thing required is patience. Now let's begin. We begin with distance because distance feels simple. You know what it means to move from one place to another. You know what it means to arrive. Your intuition was built for this. It evolved in a world where distance meant effort, time, and fatigue, and where most distances that mattered could be crossed within a lifetime, often within a day. When we say something is far away, we usually mean it takes longer to get there. Minutes instead of seconds, hours instead of minutes, a day instead of an hour. Distance, in everyday life, is almost perfectly interchangeable with travel time. Even when we use numbers, they're quietly converted into experience. A kilometre becomes a short walk. 100 kilometres becomes a long drive. You do not imagine the number itself. You imagine the duration, the boredom, the fuel gauge slowly dropping. This intuition works remarkably well on Earth. It works across cities, continents, even across the planet. The Earth is large enough to feel impressive, but small enough that distance still behaves the way we expect. You can leave one side and reach the other within a single human life. Signals, vehicles, and people can cross it. Nothing on Earth is permanently unreachable by scale alone. Because of this, your intuition carries an assumption that distance is a challenge to be overcome, not a condition to be accepted. Given enough time, enough technology, or enough determination, distance feels like something that can always be reduced. This assumption is the first thing that will fail. To see where it fails, we slow down. We strip distance of effort and replace it with something more fundamental: time. Not human time, measured by schedules and impatience, but physical time, the time required for anything to influence anything else. Information cannot move instantly. Force cannot act without delay. Causality itself moves at a finite speed. This is not a technical detail. It is a structural feature of the universe, and the maximum speed at which anything can happen, anything can be known, anything can affect anything else, is the speed of light. At first, this sounds abstract, but in everyday life, the speed of a light feels infinite. Light crosses a room in a fraction of a second. It circles the Earth multiple times in a single heartbeat. There is no waiting, no noticeable delay. Cause and effect feel immediate. So we anchor it to experience again. We imagine a conversation. When someone speaks across a room, the sound arrives slightly later. Across a city, the delay is obvious on a video call. Across the planet, the delay becomes awkward. We talk over each other. We pause. We adapt. Now replace sound with light. Replace air with vacuum. The delays shrink dramatically, but they do not disappear. Light takes a little over 1 second to travel from the moon to the Earth. 1 second. That number feels small. It fits comfortably inside intuition. You could pause your speech for 1 second. You could hold your breath. You could blink. But notice what just happened. Distance has stopped being something you cross and started being something you wait for. We extend the same process. Light from the sun takes about 8 minutes to reach Earth. 8 minutes. If the sun were to vanish, not explode, not dim, simply vanish, the Earth would continue orbiting empty space for 8 minutes, feeling warmth that no longer exists, because would be separated from effect by time, not by space. 8 minutes is still manageable. You have waited longer for a train. You have stared at a clock for 8 minutes. Intuition still holds. So we go further. Light takes about 5 hours to reach Pluto. 5 hours. A work shift. A transcontinental flight. You could watch a movie. You could fall asleep and wake up. Information from the sun takes half a day to arrive at the edge of what used to be considered the solar system. Already, something subtle has changed. The solar system is no longer a place you imagine as a cluster of objects. It has become a region of delayed influence. The sun you see at Pluto is not the sun that exists now, but the sun that existed half a day ago. We repeat the same number again, because repetition is how intuition bends. 5 hours. 5 hours of waiting. 5 hours where nothing you do can make the signal arrive sooner. 5 hours where distance has become frozen into time. Now we leave the solar system. Light from the nearest star takes a little over 4 years to reach Earth. 4 years, not metaphorically, literally. The light entering your eyes tonight began its journey before recent elections, before global events, before personal changes in your life. The star you see is not a star as it is, but as it was. 4 years is long enough for memory to blur, long enough for technology to change, long enough for a child to grow. Distance has now become historical. Say the number again. 4 years. 4 years of uninterrupted travel at the maximum speed allowed by reality. 4 years where nothing overtakes the signal. 4 years where the universe enforces separation not by walls, but by time itself. At this point, intuition begins to resist. The mind tries to compress. It tries to imagine a faster ship, a shortcut, a clever trick. But this is not about engineering. This is about structure. There is no faster lane. We continue anyway. The Milky Way galaxy is about 100,000 light-years across. Light-years are no longer a convenience here. They are the only unit that still makes sense. 100,000 years. Repeat it. 100,000 years for light to cross a single galaxy. Not to visit every star, not to explore, just to go from one side to the other. 100,000 years ago, human civilization did not exist. Agriculture did not exist. The species you belong to was barely distinguishable from its ancestors. And yet, that is the amount of waiting built into the width of our home galaxy. Distance has now become evolutionary. At this scale, old units fail completely. Kilometers are meaningless. Even years start to lose their shape. We're no longer dealing with travel. We're dealing with causality stretched across deep time. And we are still not close to the scale of the universe. So we pause here, not to reflect, but to stabilize. What we now understand is simple, but uncomfortable. Distance is not primarily about space. It is about time delay. It is about how long reality takes to respond to itself. We repeat this understanding because repetition is the only way it becomes stable. Distance is waiting. Distance is delay. Distance is the time it takes for the universe to notice itself. When distances are small, waiting disappears and intuition survives. When distances grow, waiting dominates and intuition collapses. Nothing about this is dramatic. Nothing is accelerating, nothing is pushing outward. The universe is not trying to impress you. These delays exist quietly, continuously, everywhere, whether or not anything is watching. Even within the Milky Way, most stars are permanently separated from one another by tens, hundreds, or thousands of years of waiting. No conversation can occur faster. No synchronization is possible. Each region exists in a slightly different temporal slice of the same structure. This is why words like nearby quietly lose meaning. A star can be nearby in space and still unreachable in time. It can be close enough to map precisely and still forever outside any causal loop you could participate in. We're not yet talking about the universe as a whole. We're not even close, but the failure has already begun. The idea that distance is something to be crossed has been replaced with the understanding that distance is something built into reality itself. This is the intuition we will now carry with us as the scale continues to increase. Now that distance has shifted from movement to waiting, we can no longer pretend that space is simply an empty backdrop. The next failure of intuition comes from something even more familiar location. The idea that things exist at places, and that those places can be meaningfully compared. On Earth, location feels absolute. You are here, not there. Two cities are separated by a measurable gap. Maps work. Directions work. You can point. Even when you travel long distances, the structure remains stable. North stays north. East stays east. Locations stack neatly inside one another. This intuition survives only because the scale is small. As soon as we step beyond the solar system, location begins to soften. Stars are not arranged like landmarks. There is no up or down, no central reference point that feels privileged. The Milky Way does not have a front or a back. It is not oriented toward anything. Your mind tries to impose a frame anyway, because that is what it has always done. We resist that impulse. Instead of asking where something is, we ask when its influence arrives. Location is no longer defined by coordinates alone, but by delay. Two stars separated by 10,000 light-years are not merely far apart. They exist in versions of reality that are 10,000 years out of sync. Say that again slowly. 10,000 years out of sync, not metaphorically, physically. Any change at one location becomes known at the other only after 10,000 years of waiting. Not because of ignorance, not because of obstacles, but because that is how the universe is built. We repeat the number, 10,000 years, 10,000 years of delay, 10,000 years where nothing connects those regions, 10,000 years where each evolves independently, unaware of the other's present. At this point, the idea of a single, shared now begins to fracture. In everyday life, now feels universal. What is happening here feels like it is happening everywhere at the same time. News travels fast enough that the illusion holds. The sun rises for you and sets for someone else, but you accept that as a surface detail, not a deep structural issue. But at large scales, there is no universal present. There is no cosmic clock ticking in unison. Each location carries its own slice of time forward, and those slices do not align. This is not philosophy, it is observation. When we look at a distant galaxy, we are not seeing it as it is. We are seeing it as it was, and the farther away it is, the older the image becomes. 1,000,000 light-years means 1,000,000 years of delay. 100 million light-years means 100 million years of delay. Say the numbers again, 1,000,000 years, 100 million years, not as abstract history, but as enforced waiting. That light has been travelling continuously, uninterrupted, since before entire species appeared and disappeared on Earth. Location has now turned into time depth. At this stage, intuition usually tries to rescue itself by imagining that this is just a limitation of observation, that if we could somehow be there, the problem would disappear. But this is another quiet failure. Being there does not collapse the delay elsewhere, it simply shifts which delays you are subject to. No position gives you access to a universal present, because no such present exists. This forces a new understanding. The universe is not a three-dimensional stage evolving in time. It is a four-dimensional structure where different locations are embedded at different temporal depths relative to one another. Space and time are not separate containers. They are fused into a single geometry. We do not need equations to accept this. We only need to accept delay. Repeat the core idea again, because it must settle. There is no single now across the universe. There is only local now, surrounded by layers of delayed information. Every direction you look is a different time. Every distance is a look into the past. Now we increase the scale carefully. Galaxies are not sprinkled evenly through space. They form clusters, hundreds or thousands bound together by gravity. Light takes millions of years to cross these clusters. Millions of years. Repeat it. Millions of years of delay within a single gravitational neighborhood. Between clusters lie vast regions with almost nothing in them. Not empty in the everyday sense, but so thinly populated that matter becomes rare. Crossing these regions with light takes tens of millions of years. Distance has now become geological, then planetary, then biological, and still we are only dealing with small fractions of the observable universe. As the scale increases, something else begins to fail the idea that the universe is static. When delays stretch into tens or hundreds of millions of years, change is unavoidable. Stars are born and die. Galaxies collide and reshape. Entire structures evolve while their light is still travelling. This means that when we map the universe, we are not mapping a single moment. We are stitching together a collage of different eras. Nearby regions are seen as they are now. Distant regions are seen as they were long ago. The universe you see is temporally layered. Say it again, temporally layered, not because of perspective, but because of physics. This has consequences that intuition strongly resists. There is no correct snapshot of the universe as a whole. There is no image that captures everything at once. Any attempt to do so must mix times, because that is the only information available. Even the idea of simultaneity collapses. Two events that appear simultaneous from one location may not be simultaneous from another. This is not a trick. It is a direct result of finite signal speed. At human scales, the effect is negligible. At cosmic scales, it is dominant. We pause again to stabilize because the mind tries to slip back into old frames. What we now understand is not that the universe is confusing, but that our inherited intuitions were built for a different regime. Location is not just where something is. It is when you can know about it. Distance is not just separation. It is enforced delay. The universe is not experienced as a synchronized whole, but as a patchwork of times, stitched together by traveling light. Nothing here is speculative. Nothing relies on unknown physics. This is the foundation upon which everything else rests. And now that location itself has softened into time, we are ready to confront a scale where even this understanding will begin to strain. Once location dissolves into time, the next intuition to fail is size, not distance, not separation, but the idea that the universe has a shape you could, in principle, stand outside of and describe. In everyday experience, size is comparative. A house is larger than a person. A city is larger than a house. A continent is larger than a city. These comparisons work because all of them exist within the same frame. You can imagine zooming out. You can imagine fitting smaller things inside larger ones. Size feels like containment. This intuition holds as long as there is an outside. So we begin again with something familiar. The Earth has a size. You can walk around it. You can draw it on a map. Even if you never do these things, you trust that someone could. The planet fits comfortably inside imagination because it is finite and bounded. The solar system stretches that comfort, but does not break it. The orbits are large, but still diagrammable. You can picture the sun at the center and planets tracing paths around it. The distances are long, but the structure feels stable. Then we reach the galaxy, and the picture already begins to blur. The Milky Way is not a neat disk with stars evenly spaced. It is a rotating system with spiral arms, dust lanes, and vast regions of darkness. You can still draw it, but the drawing is symbolic. You're no longer imagining placement. You're imagining statistical structure. This is the first warning sign. The observable universe contains hundreds of billions of galaxies, not stars' galaxies, each one containing hundreds of billions of stars of its own. These numbers are not introduced to impress. They are introduced because they quietly invalidate containment-based intuition. Say the scale slowly. Hundreds of billions of galaxies. Hundreds of billions of galaxies, each separated by millions of light years. Hundreds of billions of independent stellar systems, each with its own internal history. At this point, the mind often reaches for an image, a bubble filled with points, a cosmic snow globe, a sphere with galaxies scattered inside. This image is wrong, not because the universe is not large, but because the idea of a container is doing work it is no longer allowed to do. To understand why, we shift away from objects and toward observation. There is a limit to how far we can see, not because the universe ends there, but because light has only had a finite amount of time to travel. The universe has an age. Light emitted before a certain moment simply has not had time to reach us yet. This creates a horizon, not a wall, not a boundary, but a limit of visibility. Beyond that limit, there may be more universe, or there may not. We do not know. What matters is that we cannot observe it. Repeat this carefully. The observable universe is not the entire universe. It is the portion of the universe from which light has had time to reach us. Now we put scale back in, gently but relentlessly. The observable universe has a radius of about 46 billion light-years. This number immediately causes resistance. The universe is about 13 billion years old, so intuition expects the radius to be 13 billion light-years. This is where intuition collapses again. Space itself has been expanding while light was travelling. The distance the light had to cross increased during the journey, so the regions we can now observe are much farther away than 13 billion light-years. Say the number again, 46 billion light-years, not in diameter, in radius. The diameter is over 90 billion light-years. Repeat it, 90 billion light-years across. Now we slow down and repeat it in different forms, because this number must lose its familiarity. 90 billion years of waiting for light to cross the observable universe. 90 billion years of enforced delay from one edge of visibility to the other. 90 billion years where cause and effect are separated not by obstacles, but by the geometry of space itself. At this scale, the word size becomes unstable. There is no outside perspective. There is no place you could go to see the universe as a whole, because the universe is not embedded in a larger space that allows such a viewpoint. This is not a limitation of travel, it is a limitation of meaning. The universe does not have a centre in the way intuition expects. From any location, you observe the same kind of horizon. Every observer sees themselves at the centre of their observable universe, not because they are special, but because observation is local. Say this again. Every observer sees themselves at the centre of what they can observe, not because the universe is arranged around them, but because light reaches them symmetrically from all directions. This destroys another inherited assumption that size implies orientation. There is no cosmic north, no outer edge you could point toward, no direction that leads out of the universe. Even the phrase expanding universe often misleads intuition. It sounds like an explosion into empty space, but there is no external space into which expansion occurs. Space itself is stretching. Distances between galaxies increase not because galaxies are moving through space, but because the space between them is growing. We repeat this slowly. Galaxies are not flying away from a central point. The distances between all distant galaxies are increasing everywhere at once. Expansion is uniform. There is no privileged location. At small scales, gravity overcomes expansion. Galaxies remain bound. Clusters remain intact. At large scales, expansion dominates. Structures drift apart. The universe changes not by rearranging contents, but by changing the scale of separation itself. Now intuition reaches for its last defense that even if the universe is vast, it must still be finite. That somewhere, beyond the observable horizon, there must be an edge. This is where we must be precise. We do not know whether the universe is finite or infinite. Both are consistent with current observations. What we do know is that if the universe is finite, it has no edge. It would be more like the surface of a sphere than the boundary of a box. You could travel forever without encountering a wall, eventually returning to where you started. Say it again. Finite does not mean bounded. Finite does not mean enclosed. Finite does not mean there is an outside. This is not speculation for drama. It is the calm result of how geometry works when applied to space itself. We pause again to stabilize. What we now understand is subtle but firm. The universe is not an object sitting in space. It is the space. Size is not something measured against an external reference. It is an internal property of the structure itself. There is no zooming out beyond everything. There is no external frame where the universe becomes small enough to fit into intuition. The failure here is final. The idea of size as containment does not survive cosmic scale. And yet, we are still only dealing with structure. We have not yet confronted time itself as a global feature. That comes next. Once size loses its meaning as containment, time becomes the next structure we are forced to examine. Not time as you experience it measured by clocks, schedules, and aging, but time as the universe enforces it. Human intuition treats time as a steady background. It flows, it passes, events happen within it. This intuition is so deep that it usually goes unexamined. You assume that time is the same everywhere, moving forward at the same rate, providing a universal order in which events unfold. This assumption works locally. It works on Earth. It works within a lifetime. It even works across centuries of recorded history, but it does not survive scale. To see why, we begin with something stable change. Time is how change is ordered. One thing happens, then another, cause precedes effect. This ordering is not negotiable. It is built into physics. But the rate at which time passes is not universal. This is not introduced as an abstract theory. It is an observed fact. Clocks do not agree when they experience different conditions. Clocks in motion tick differently than clocks at rest. Clocks deeper in a gravitational field tick differently than clocks farther away. At everyday scales, the differences are tiny, so tiny that intuition ignores them, but the differences are real, measurable, and cumulative. We anchor this again to experience. Satellites orbiting Earth must constantly correct their clocks, not once, continuously. Without these corrections, GPS would drift by kilometers each day. Your phone would tell you that you are somewhere you are not. Navigation would quietly fail. Say it again. Satellites experience time differently than you do. Not because of malfunction, not because of error, because time itself flows differently under different conditions. At this point, intuition usually attempts to isolate the effect. It tries to label it as a technical detail, something engineers deal with, not something fundamental. That move will not survive what comes next. As we move to cosmic scales, differences in time accumulation become unavoidable. Stars deep in galaxies experience time differently than stars drifting through intergalactic space. Regions near massive structures age more slowly than regions far from them. There is no universal cosmic clock ticking in synchrony across the universe. Repeat that slowly. There is no universal time shared by the entire universe. Now we combine this with what we already know about delay. Each location already exists in a different temporal slice because of light travel time. Now we add that time itself flows differently at different locations. The universe is not just temporally layered by observation, it is temporally uneven by structure. This is where intuition truly destabilizes. You want to ask which clock is correct, which time is real, but that question assumes a reference that no longer exists. There is no master clock outside the universe against which all others can be compared. Each clock is correct along its own path. Each measures its own proper time. There is no contradiction. There is only locality. We repeat the core idea again, because it must settle. Time is local. Time is experienced along paths, not across space as a whole. There is no single timeline that everything follows. At small scales, the differences are negligible. At large scales, they dominate. Now we extend this understanding backward. The universe has an age, about 13.8 billion years, as measured along paths like ours. This number often gets treated as a simple timestamp the moment everything began. But this framing is misleading. The beginning of the universe was not an explosion at a point in space. It was a change in the state of space itself. Everywhere was once hotter, denser, and more uniform. There was no center, there was no edge. Time itself emerges from this process. The earliest moments are not just difficult to observe, they are difficult to define. The laws of physics we rely on break down as we approach those conditions. We do not say this for drama. We say it because it marks a real boundary of understanding. As we look deeper into space, we look further back in time. Eventually, we reach a point where the universe was opaque. Light could not travel freely. Before that, the concept of seeing loses meaning. The cosmic microwave background marks this boundary. It is the oldest light we can observe. It does not show stars or galaxies. It shows the universe when it first became transparent. Say it again. This light is not from objects. It is from space itself cooling enough to let light move. This moment happened about 380,000 years after the universe began. Before that, photons were trapped. After that, they were free. This boundary is not arbitrary. It is enforced by physics, and it means that there is a limit to how far back observation can go. Beyond that limit, we must infer rather than see. Now we stabilize again. What we understand now is layered. Time is not a uniform background. It flows differently depending on motion and gravity. Observation always looks backward, and the universe itself has a history that is not accessible in full detail. We separate carefully. Observation, we measure time dilation, we detect ancient light, we map cosmic structure. Inference, we reconstruct earlier states using models. Modeling, we extrapolate laws beyond tested regimes. And then there is a boundary. We do not know what happened before the earliest moments we can describe, not because the universe is hiding something, but because our current tools no longer apply. This we don't know is not a gap waiting for mysticism. It is a stable edge of knowledge. Say it again. We don't know what physics describes the earliest instance of time. We do know where our descriptions stop working. This is not a failure. It is a map. And now, with time itself revealed as local, uneven, and bounded by observation, we are ready to confront the larger structure of all the evolution of the universe as a whole, not as a snapshot, but as a process unfolding across scales that intuition was never designed to hold. Once time is no longer universal, evolution becomes unavoidable. Not biological evolution, but structural change, the fact that the universe is not merely large, but actively different at different moments, with no single moment that can be called definitive. Human intuition prefers static things. A mountain is a mountain, a planet is a planet. Even when change is acknowledged, it is treated as surface variation. The underlying object is assumed to persist. This intuition fails when the object is the universe itself. We begin again with something stable, the night sky. For most of human history, the stars appeared fixed, patterns repeated, generations rose and fell under the same constellations. The universe felt eternal, unchanging, reliable. This was not ignorance. It was a reasonable conclusion drawn from available evidence. On human timescales, the universe does not noticeably change. But scale exposes the illusion. When we look deeper into space, we do not just see farther, we see earlier, and earlier versions of the universe are not the same as the one we inhabit now. Galaxies in the distant universe look different. They are smaller, more irregular, more chaotic. Collisions are more common. Star formation is more intense. The quiet, structured universe around us is a late development. Say it again. The calm universe you see now is not typical of the universe's past. This is not interpretation. It is observation. Telescopes do not show distant galaxies because they are exotic. They show them because their light has taken billions of years to arrive. Distance has turned into history again. Now we stretch this understanding carefully. The universe began hot, dense, and nearly uniform. Not uniform in the sense of empty, but uniform in structure. Matter and energy were spread smoothly, with only tiny fluctuations. These fluctuations were small differences of 1 part in 100,000. Repeat that number, 1 part in 100,000. Differences so small that intuition would dismiss them as irrelevant. But gravity amplifies differences. Over time, denser regions pulled in more matter, less dense regions lost matter. Structure emerged not because the universe was designed to form galaxies, but because small variations were allowed to grow. This process is slow, painfully slow by human standards. Hundreds of millions of years pass before the first stars ignite. Billions of years pass before large galaxies stabilize. Say it again. Billions of years for structure to mature. Now we pause because intuition tries to compress this into a timeline it can follow. It imagines a sequence of events, neatly ordered, like chapters in a book. But cosmic evolution is not a story. It is a statistical process unfolding everywhere at once. There was no moment when the universe decided to form galaxies. There was no switch. There was only time, gravity, and initial conditions doing what they must. As expansion continues, something else happens. The universe cools, energy spreads out, processes slow, the density of matter drops. This cooling is not incidental, though it controls what can exist. Early in the universe, temperatures were so high that atoms could not form. Later, atoms formed. Later still, stars formed. Even later, heavy elements accumulated. Planets became possible. Chemistry became complex. Each step depends on the previous one, not by intention, but by constraint. We repeat this gently. The universe changes because conditions change. Conditions change because expansion stretches space. Expansion stretches space because that is what the universe does. This chain has no goal. It has no endpoint in mind. It simply unfolds. Now we confront a subtle but critical failure of intuition. When we say the universe is expanding, intuition imagines a process that happened in the past and is now mostly over, like an explosion that slows down. This is wrong. Expansion is not a historical event. It is an ongoing feature. Space is still stretching. Distances between distant galaxies are still increasing, and the rate of this expansion is not slowing. It is accelerating. Say it again. The expansion of the universe is accelerating. This statement often triggers emotional responses: surprise, unease, speculation. We do none of that. We treat it as a measurement. Distant galaxies are receding faster now than they were in the past, not because they are being pushed, but because the expansion rate itself is increasing. This acceleration implies the presence of something we do not fully understand. We call it dark energy, not because it is mysterious in a dramatic sense, but because its nature is unknown. We are precise here. Observation, the expansion rate is accelerating. Inference there is a component of the universe that causes this behavior. Modeling, we describe it mathematically and call it dark energy. We do not know what dark energy is. We do know what it does. Say it again. We do not know what it is. We do know its effect. As expansion accelerates, distant regions move beyond our horizon. Their light will never reach us, no matter how long we wait, not because of distance alone, but because space itself is stretching faster than light can traverse. This introduces a permanent loss of information. Repeat it carefully. There are regions of the universe whose future light will never be observable. This is not a tragedy. It is not a narrative. It is a structural consequence. The observable universe is not only limited by age, it is limited by expansion. As time passes, the observable universe will contain fewer galaxies, not because they disappear, but because they drift beyond causal contact. The universe evolves not just internally, but in what it allows to be known. We pause again to stabilize. What we understand now is that the universe is not a static container filled with objects. It is a dynamic system whose properties change over time. Structure forms, expansion accelerates, horizons shift. And all of this happens without reference to observers. The universe does not evolve for us. We evolve within it, late arrivals inside a process that began long before and will continue long after. This is not philosophy, it is framing. We now carry a stable understanding scale is not just size, it is time, change, and loss of access. And with that frame, we are ready to confront what the universe is made of and why most of it does not behave the way intuition expects. Once evolution is accepted as structural rather than narrative, the next intuition to fail is substance. The idea that the universe is mostly made of the things you see: stars, planets, gas, light feels obvious. It feels grounded in experience. When you look out into space, luminous objects dominate. They define shape, motion, and scale. This intuition is wrong. We begin again with something familiar matter, the kind that forms atoms, the kind that emits light, the kind that makes up planets, stars, and your own body. This matter interacts through forces you recognize. It clumps, it collides, it heats up, it shines. For most of human history, this was all that was needed. Everything observed could be explained by things that glowed or reflected light. But as measurements improved, cracks appeared. Galaxies rotate too fast. Clusters of galaxies hold together too strongly. Gravitational effects are larger than the visible mass can account for. Something is missing. We repeat that carefully. The observed gravity is stronger than what visible matter can produce. This is not speculation. It is measurement repeated across scales, methods, and decades. At first, intuition tries to adjust the visible. Maybe stars are heavier than we think. Maybe gas is hiding. Maybe our models are wrong. Some adjustments help. None solve the problem. So we isolate the issue. Observation light tells us how much ordinary matter is present. Observation gravity tells us how much total matter is present. These two do not agree. The difference is large, not subtle, or not marginal. Roughly 85% of the matter in the universe does not emit light. It does not absorb light. It does not interact electromagnetically in any detectable way. Say it again. 85% of matter is invisible. We call this dark matter, not because it is shadowy or mystical, but because it does not interact with light. Now, intuition pushes back hard. If something does not interact with light, how can we know it exists? We know because gravity does not lie. Dark matter bends the paths of stars in galaxies. It shapes the motion of galaxies and clusters. It warps the path of a light itself through gravitational lensing. Repeat this slowly. We do not see dark matter, we see what it does. This distinction matters. We separate again. Observation stars move faster than visible mass allows. Observation background galaxies are distorted by unseen mass. Inference there is additional matter producing gravitational effects. Modelling, we describe this matter as dark, cold, and weakly interacting. We do not know what dark matter is made of. We do know where it is and how much there must be. Say it again. We do not know its composition. We do know its distribution. Dark matter forms vast halos around galaxies, not disks, not spirals. Roughly spherical structures extending far beyond visible stars. Galaxies sit inside these halos like luminous traces embedded in something much larger. This reverses another intuition. You might imagine dark matter as filling the gaps between stars. In reality, stars are filling the gaps within dark matter. Say it again. Galaxies are luminous islands inside dark matter oceans. This structure formed early. Dark matter clumped first because it does not interact with radiation. It began collapsing into structures while ordinary matter was still coupled to light and pressure. When ordinary matter finally cooled enough to fall into these gravitational wells, stars formed where dark matter had already shaped the landscape. Structure follows dark matter, not the other way around. Now we add the next layer. Matter itself, ordinary plus dark, accounts for only about 30% of the total energy content of the universe. The remaining 70% is dark energy. Say the numbers again. 5% ordinary matter, 25% dark matter, 70% dark energy. These are not round for convenience, they are measured. Dark energy does not clump. It does not form structures. It does not pull things together. It pushes space itself to expand faster. And unlike dark matter, which dominates on galactic scales, dark energy dominates on the larger scales. This introduces a deeper symmetry. Gravity pulls matter together locally. Expansion driven by dark energy pushes space apart globally. The universe is governed by two competing tendencies operating at different scales. Repeat that idea. Locally, gravity wins. Globally, expansion wins. This is why galaxies remain intact while clusters drift apart. This is why stars continue to orbit while the universe as a whole accelerates. Dark energy is not something added to the universe. It appears to be a property of space itself. We are precise here. Observation expansion accelerates uniformly. Inference there is a component associated with space, not matter. Modelling, we describe this with a constant energy density filling space. We do not know why space has this property. We do not know if it will change over time. This is another stable we don't know. Now intuition attempts to anthropomorphize again. It imagines dark matter and dark energy as substances waiting to be discovered, like missing chemicals. This may or may not be correct. Dark matter may be a particle. It may be something else. Dark energy may be constant. It may evolve. Or our models of gravity may be incomplete. We hold all of these possibilities without drama. What matters is what scale forces us to accept. The universe you see, the luminous one, is a minor component. The dominant structures shaping cosmic evolution are invisible to your senses and mostly indifferent to light. Say it again. Light is not the primary driver of cosmic structure. This is not humbling, it is clarifying. We pause again to stabilize. We now understand that the universe is not composed primarily of what is familiar. Most of its mass does not shine. Most of its energy does not clump. The visible universe is a thin layer riding on deeper, unseen scaffolding. This does not make the universe unknowable. It makes it legible in a different way. And now, with substance itself reframed, we are ready to confront the final failure of intuition, the idea that scale eventually stops, that if we go far enough or deep enough, the universe must become simple again. It does not. Once substance is no longer defined by what shines, the last refuge of intuition is hierarchy, the belief that the universe is built in clean layers. Small things combine into larger things, which combine into larger things still, until the structure is complete. This intuition feels reasonable. Atoms form molecules. Molecules form cells. Cells form organisms. Organisms form ecosystems. The pattern suggests completion, that if we zoom out far enough, complexity should smooth out into simplicity. At cosmic scale, this expectation fails. We begin again with something familiar: structure. On small scales, structure is sharp. A star is clearly distinct from the space around it. A galaxy has edges, arms, and a center. Even clusters of galaxies feel like objects groups with boundaries. But when we increase scale carefully, structure does not resolve, it fragments. Galaxies group into clusters. Clusters link into filaments. Filaments surround enormous voids. These voids are not empty, but they are vast regions where matter is so sparse that galaxies are rare. This pattern repeats. Say it again. Matter does not fill space evenly. It forms a cosmic web. This web is not decorative language. It is a precise description. Matter traces out long, thread-like structures tens or hundreds of millions of light-years long. Between them lie voids that dwarf the largest clusters. At this scale, the universe no longer looks like objects in space. It looks like structure imposed on emptiness. Now intuition tries to compress again. It imagines that if we zoom out further, the web itself will become a single object, that filaments will blur into uniformity. They do not. The universe becomes statistically uniform only in a very specific sense. When averaged over sufficiently large volumes, the density becomes roughly the same everywhere. But this uniformity is not visible, it is mathematical. Say it again, the universe is homogeneous in average, not in appearance. This distinction matters. There is no scale at which the universe turns into a simple shape you can hold in mind. No level where complexity stops and smoothness takes over in a way intuition can visualize. Even the largest structures we can map are not isolated. They bleed into one another. They overlap statistically. They do not form clean boundaries. This means there is no largest object in the universe in the way intuition expects. Clusters are not the top. Superclusters are not the top. The cosmic web itself does not sit inside a container that defines its edge. Hierarchy dissolves into pattern. We repeat this again. There is no final layer where structure ends. There is only scale-dependent pattern. This failure is subtle, because intuition tries to rescue itself by invoking infinity. It imagines endless repetition as a form of simplicity. But infinity does not simplify, it removes closure. Now we shift perspective carefully. Instead of asking what the universe is made of, we ask how information is distributed within it. Information does not spread evenly, it follows structure. Regions dense with matter process information rapidly. Stars form, burn, and die. Sparse regions change slowly. Time itself unfolds differently depending on environment. This means that the universe does not evolve uniformly. Different regions are at different stages of structural development, even at the same cosmic time. Say it again, cosmic evolution is not synchronized. This is not a flaw, it is a consequence of scale and causality. Because signals travel at finite speed, because gravity acts locally, because expansion stretches space, no global coordination is possible. The universe does not converge toward a final state in which everything looks the same. It diverges into regions with increasingly different futures. Some regions will continue forming stars for trillions of years, others will exhaust their fuel quickly, some will remain gravitationally bound, others will drift into isolation. We pause again to stabilize. The idea that the universe settles down is another inherited assumption. It comes from systems that reach equilibrium. The universe is not such a system. It expands, it cools, it dilutes, and in doing so, it creates conditions where fewer processes remain possible. This leads us to a controlled boundary. There is a future in which stars no longer form, not because something dramatic happens, but because the raw materials thin out and energy gradients flatten. Say it again, star formation will end not with a bang, but with exhaustion. This future is not imminent. It lies trillions of years ahead, but its inevitability is structural. As expansion continues, galaxies beyond local groups slip beyond causal contact. Eventually, only nearby stars remain visible. The night sky grows emptier. This is not speculation. It follows directly from expansion and finite signal speed. We repeat it calmly. The observable universe will shrink in content over time. Now, intuition tries to resist again by asking what comes after. What is the final shape, the final structure? This is where we must be careful. We do not know the ultimate fate of the universe in detail. We know the trends. We know the constraints. We do not know the end state. Dark energy may remain constant. It may change. Gravity may behave differently at extreme scales. New physics may emerge. This we don't know is legitimate and stable. We do not introduce it to create mystery. We introduce it to mark the boundary of extrapolation. What we can say is this: the universe does not simplify with scale. It does not converge toward a single object, a final layer, or a comprehensible whole. It remains a system whose behavior depends on scale, location, and time. Hierarchy does not terminate. Pattern does not collapse into uniformity. Complexity does not resolve into simplicity. We pause again. What we now understand is that scale does not merely add more of the same. It changes the rules by which structure exists. The universe cannot be understood as a completed object. It must be understood as an ongoing process whose features emerge and fade depending on where and when you look. This frame is stable. It does not rely on unknowns. It does not depend on speculation. And now, with hierarchy itself dissolved, we are ready to confront the most counterintuitive realization of all, that even the laws we rely on may not be universal across all scales in the way intuition assumes. Once hierarchy dissolves, the last place intuition retreats to is law, the belief that whatever the universe looks like, it must at least obey the same rules everywhere, at every scale, in the same way. This belief feels safe. Physics feels reliable. Drop an object, it falls. Heat flows from hot to cold. Forces balance. Patterns repeat. The universe may be vast, but surely its laws are uniform. This intuition is mostly right and dangerously incomplete. We begin again with something stable physical law as tested. On Earth, in laboratories, across the solar system, the same equations work. Gravity behaves predictably. Electromagnetism behaves predictably. Quantum mechanics behaves predictably, if not intuitively. This success builds trust, and that trust is justified. But scale introduces pressure. The laws of physics are not recipes. They are models. They describe relationships between quantities under specific conditions. When conditions change beyond tested regimes, the models are forced to stretch. At small scales, quantum mechanics dominates. At planetary scales, classical mechanics works. At stellar and galactic scales, gravity rules. These domains overlap smoothly until they do not. The first major fracture appears at extreme density. Inside black holes, our models break. Gravity becomes so strong that space and time themselves collapse into singular behavior. The equations we trust return infinities. Predictions lose meaning. Say it again. Our laws do not fail gradually. They fail catastrophically. This is not because reality stops obeying rules, it is because our descriptions stop applying. Now intuition tries to isolate the problem. Black holes feel exotic, rare, peripheral. They are not. Every large galaxy hosts a supermassive black hole at its centre, millions to billions of times the mass of the Sun, compressed into regions smaller than the solar system. These objects shape galaxy evolution. They regulate star formation. They influence structure across vast distances. Black holes are not edge cases. They are structural components. Say it again. Black holes are common, not exceptional. Now we add scale again. The early universe was also an extreme regime. Densities were enormous. Temperatures were extreme. Forces that are separate today were unified. Under those conditions, our current laws do not apply cleanly. We infer early behavior using extrapolation. We test models against relic signals, but we do not have direct access. This creates another stable boundary. Observation works where signals exist. Modelling works where extrapolation remains controlled. Beyond that, law itself becomes uncertain. We repeat this carefully. Physical laws are tested locally. Their universality is inferred, not guaranteed. This is not skepticism, it is precision. Now intuition resists strongly. If laws are not guaranteed everywhere, does anything hold the universe together? Yes, consistency holds. Wherever we can test, the same underlying principles appear. Symmetries repeat, conservation laws persist, patterns echo across scale. But the form those laws take can change. Gravity behaves differently when space itself is dynamic. Quantum effects dominate when scales shrink. Thermodynamics governs when systems grow large. There is no single law that rules all scales in the same way. There is a framework of overlapping descriptions. Say it again. Laws are scale-dependent descriptions of deeper consistency. This reframes a common misunderstanding. Physics does not seek a single equation that replaces all others. It seeks coherence rules that reduce to known behavior where tested and extend without contradiction where possible. Now we confront another intuitive failure. You may imagine that if we could reach the smallest scale, the fundamental scale, everything would become simple again. A final set of rules, a clean foundation. We do not know if this is true. Quantum gravity remains unsolved. We do not yet know how space-time behaves at the smallest possible scales. Competing models exist. None are confirmed. This is another we don't know, introduced carefully and without drama. We do not know how space and time behave at the Planck scale. We do know that our current descriptions cannot be simultaneously correct there. This ignorance is not vast. It is narrow. It sits at a specific junction where scale compresses beyond testability. Now we pull back. What we understand is that law itself is not immune to scale. The universe does not come with a single instruction manual that applies unchanged everywhere. Instead, it comes with regularities that manifest differently depending on context. This is not a weakness. It is how complex systems behave. Weather follows physics. Climate follows physics. Yet you do not use the same equations to predict a storm and to predict atmospheric circulation over centuries. Scale forces new descriptions. The universe is the ultimate scale-stretch system. We pause again to stabilize. We now understand that intuition fails not because the universe is chaotic, but because it is structured across regimes that human experience never encounters. Distance becomes delay, location becomes time, size loses containment, time becomes local, evolution becomes structural, substance becomes invisible, hierarchy dissolves, law becomes contextual. This is not a collapse of understanding, like it is its expansion. And now, with even law reframed, we are ready to confront the final challenge: how a human mind, built for survival at small scales, can remain stable inside a universe that does not care about intuition at all. Once law itself becomes contextual, the remaining challenge is not scientific, it is cognitive. The universe no longer fails to make sense. Your intuition does. Human intuition did not evolve to track billions of years, invisible mass, expanding space, or delayed causality. It evolved to throw objects, recognize faces, and survive immediate threats. It compresses, it simplifies, it fills gaps with familiar structure. At cosmic scale, this becomes a liability. We begin again with something familiar understanding. When you say you understand something, you usually mean you can imagine it, you can picture it happening, you can simulate it mentally. This definition works for everyday systems, it works for machines, terrain, and social interactions. It fails for systems whose scale exceeds mental simulation. The universe is one of those systems. So we must separate two ideas that intuition insists on merging. Understanding does not require visualization. Understanding requires constraint. We repeat that slowly. To understand is not to imagine. To understand is to know what must happen and what cannot. This is how science operates at scale. You cannot visualize a billion years, but you can understand that radioactive decay follows a probability curve. You cannot picture curved space-time, but you can understand that mass alters motion and delay. You cannot imagine dark matter, but you can understand that gravity requires it. This is not a workaround. It is the correct mode of comprehension. Now intuition pushes back again. It wants a story, a narrative with beginnings, middles, and ends, characters, causes that feel direct. The universe does not provide this. It provides constraints, regularities, and consequences. We repeat this calmly. The universe does not tell stories. It enforces relationships. At this point, many explanations fail because they try to restore narrative comfort. They use metaphor too long. They turn models into literal pictures. They turn equations into characters. We do not do that here. Instead, we retrain intuition to tolerate abstraction without collapse. We do this by repetition, not persuasion. Distance is delay. Delay is causality. Causality is finite. Repeat it again. Scale is not size. Scale is change in rules. Repeat it again. Observation is not reality. Observation is delayed information. Repeat it again. The universe you perceive is not the universe as it is now. It is the universe as it was. Each repetition weakens the reflex to imagine and strengthens the ability to accept structure without imagery. This is cognitive training. Now we introduce a controlled boundary. There are aspects of the universe that no human will ever directly experience. No one will watch a galaxy form from beginning to end. No one will see the universe age by billions of years. No one will observe space expanding. This does not mean these things are abstract. It means they are distributed across time and space beyond individual access. We say this without disappointment. Science does not aim to make the universe feel familiar. It aims to make our expectations stop failing. Now we address a subtle error. You might think that better instruments eventually fix intuition, that more powerful telescopes will make things feel real. They will not. They will add data, they will sharpen constraints, but intuition will still fail at scale. This is why numbers repeat so often. This is why units change. This is why we return to time and delay again and again. Not to inform, to stabilize. Now we connect this to modeling. Models are not pictures, they are compressed relationships. They tell us what changes when something else changes. They tell us what remains invariant. A good model survives scale by abandoning visualization. This is why the most accurate descriptions of the universe are not intuitive, they are mathematical. Not because mathematics is mystical, but because it is precise without imagery. Now intuition tries one last move. It tries to ask what all of this means. We do not answer that question. Meaning is not a physical property. It is not constrained by observation. It is not required for prediction. We set it aside without judgment. What we do instead is return to reliability. Despite every failure of intuition we have exposed, the universe is not arbitrary. It is consistent. Its behavior is repeatable. Its structure obeys rules that can be tested. This is why spacecraft reach other planets. This is why predictions match observation. This is why models improve. Understanding at scale does not feel like clarity. It feels like stability. You stop reaching for images that break. You stop expecting closure where none exists. You stop demanding a single frame that contains everything. We repeat this again. Understanding is stability, not familiarity. Now we pause before the final descent. What we now understand is not a list of facts. It is a change in how facts are held. The universe is not too big to understand. It is too big to imagine. Once that distinction is accepted, cognitive overload disappears. You're no longer trying to compress the universe into a mental picture. You're allowing it to remain large, slow, uneven, and partially inaccessible. This is not surrender, it is alignment. And now, with intuition retrained to tolerate scale without collapse, we are ready to return to where we began, not to add new information, but to close the loop with a stable frame that can hold the universe without distortion. We return now to the familiar, not to simplify, but to test whether intuition has actually changed. We return to the night sky not as an image, but as a structure you now carry differently. You still see points of light. That has not changed. What has changed is what those points mean. Each point is not a place, it is a delay. It is not an object as it exists now. It is an event that already happened. The sky is no longer a surface above you. It is a record stretched across time. We repeat this calmly. The night sky is a history, not a map. This reframing removes a persistent error. You're not looking outward. You're looking backward. Every direction is a different depth of time. Near stars, a shallow history. Distant galaxies, a deep history. This does not make the universe feel less real. It makes it more precise. Now we reconnect this to scale. When you look at the moon, you see it as it was 1 second ago. When you look at the sun, you see it as it was 8 minutes ago. When you look at the center of the Milky Way, you see it as it was 26,000 years ago. When you look at distant galaxies, you see them as they were billions of years ago. Say the progression again. Seconds, minutes, thousands of years, billions of years. Nothing about this progression is optional. It is enforced by the speed of light. This means that the universe does not present itself as a single object. It presents itself as a layered archive. Now, intuition often tries to unify this archive. It tries to imagine what the universe looks like right now. This question has no operational meaning. There is no observation that corresponds to right now across the universe. There is only local now, surrounded by delayed information. We repeat it again. There is no cosmic present. This is not a limitation of instruments. It is a feature of reality. Now we connect this to something else that feels familiar: prediction. In everyday life, prediction feels local and short-term. You predict weather tomorrow, you predict traffic, you predict outcomes within systems that change slowly compared to your response time. At cosmic scale, prediction changes character. We do not predict the future of individual stars billions of years ahead. We predict distributions. We predict probabilities. We predict statistical trends. This is not because the universe is random. It is because scale destroys specificity. Say it again. Scale replaces certainty with distribution. This is why cosmology does not tell you where a specific galaxy will be in 10 billion years. It tells you how populations evolve. It tells you how structure thins. It tells you how horizons shift. This is the correct level of description. Now we revisit something that felt abstract earlier: expansion. Expansion is not something you watch. You do not see galaxies stretch apart like dots on a balloon. You infer expansion from redshift, from background radiation, from consistent patterns across the sky. Expansion is known because models that include it succeed, and models that exclude it fail. This is how scale knowledge works. We pause again to stabilize. Understanding at cosmic scale is indirect. It relies on consistency across many weak signals. No single observation proves expansion, dark matter, or dark energy. The case is cumulative. This is another intuition that had to be retrained. You're used to single causes producing visible effects. At scale, understanding emerges from convergence. Now we return to limits. There are things we will never observe directly. Regions beyond the cosmic horizon, the earliest moments of time, the exact nature of dark components. These are not failures of ambition, they are consequences of structure. We repeat this calmly. Some information is permanently inaccessible. This does not collapse science, it defines it. Science does not require total access. It requires bounded questions and testable implications. Now we confront one more quiet intuition failure. You may feel that if the universe is this large, this old, this indifferent to observation, then human understanding must be insignificant. We do not accept that framing. Significance is not a physical variable. It does not scale with size. What matters is coherence. The universe is intelligible, not because it fits us, but because its behavior is consistent enough to be modeled. We repeat it again. The universe is intelligible without being intuitive. This is the stable position. Now we connect everything. Distance became delay. Delay became history. History revealed evolution. Evolution exposed unseen structure. Structure forced new laws. New laws broke intuition. Broken intuition was replaced with constraint-based understanding. This chain did not branch. Each step forced the next. We have not added meaning. We have not added narrative. We have removed error. We pause here before the end. What you now carry is not an image of the universe. It is a way of holding scale without collapse. You no longer expect the universe to feel familiar. You no longer demand closure. You no longer mistake visibility for importance. This is not enlightenment. It is calibration. And with that calibration in place, we are ready to conclude not by expanding further, but by returning fully to the beginning, to show that what once felt obvious now quietly fails to survive even casual inspection. We arrive now at the edge of completion, not by adding scale, but by removing the last remaining shortcuts intuition still tries to use. The universe has not become more complicated. Your expectations have become more precise. We return again to the opening idea, something familiar that was never as simple as it seemed. The universe is big. That sentence remains true. What has changed is that it no longer carries false comfort. Big does not mean reachable. Big does not mean containable. Big does not mean fully observable. Big means delayed, layered, evolving, and partially inaccessible by structure alone. We repeat this carefully. Size is not magnitude. Size is consequence. This reframing matters because it removes the last impulse to shrink the universe mentally until it fits. Now we examine one final intuition that quietly persists, that understanding should eventually feel complete. In everyday systems, completeness is possible. You can fully understand a machine. You can fully understand a route. You can fully understand a rule set. The universe is not that kind of system. This does not make it vague. It makes it open. Understanding at cosmic scale does not converge to a final picture. It converges to a stable framework that accommodates revision without collapse. We repeat this. Understanding is not closure. It is resilience. Now we separate one last time. Observation gives us data. Inference connects data into patterns. Models encode those patterns into testable structures. None of these claim finality. This is not a weakness. It is the only stance that survives scale. Now we confront the idea of ignorance one last time. Earlier we said we don't know at specific boundaries the nature of dark matter, the origin of dark energy, the behavior of space-time at the smallest scales. These unknowns did not feel threatening because they were introduced after structure was built. This is intentional. Unknowns only destabilize when they are used to replace explanation. Here, they mark edges. Say it again. Unknowns are boundaries, not gaps. Within those boundaries, understanding is strong. We know how the universe expands. We know how structure forms. We know how gravity shapes motion. We know how light encodes history. We know why observation is delayed and incomplete. These are not fragile claims. They are supported across methods, instruments, and scales. Now intuition tries one last move. It tries to imagine an observer outside the universe, looking in. We release that image. There is no outside vantage. There is no external reference frame. There is no position from which the universe can be seen as a whole. This is not a limitation of imagination. It is a statement about geometry. The universe does not sit inside anything else. We repeat it calmly. There is no outside. This removes the last false expectation. Now we pause and assess what remains. What remains is a universe that is finite in age, possibly infinite in extent, expanding without center, structured by invisible components governed by laws that depend on scale, observed only through delayed signals. None of these statements conflict. They reinforce one another. This is not a strange universe. It is a consistent one. Now we reconnect this to the human position not in terms of meaning, but in terms of placement. We are not at the center of the universe. We are not at the edge. We are not at a privileged time. We are simply located somewhere inside it, subject to the same constraints as everything else. This is not diminishing, it is clarifying. Our measurements work because we are inside the system, not outside it. Our models succeed because they respect locality, delay, and scale. Now we approach the final stabilization. At the beginning, intuition insisted that the universe should be imaginable if explained well enough. That insistence has been removed. You no longer expect imagery to carry truth. You no longer expect scale to compress. You no longer expect laws to feel the same everywhere. You expect constraint, delay, and structure. This expectation does not break under pressure. We repeat the final calibration. Understanding does not mean I can picture it. Understanding means I know how it must behave. This is the frame that survives. Now, without introducing anything new, we prepare to end by returning fully to the opening where familiarity first misled. The universe is something you have always lived inside. What changed is not the universe. What changed is the intuition you bring to it. Tonight, we began with something familiar, because familiarity is where intuition hides its errors most effectively. The universe felt known because it was always present. The sky was always there. Distance, size, and time felt manageable because they rarely exceeded human experience. Nothing about the universe has changed since then. What has changed is the frame through which we hold it. We return one last time to the opening idea, without adding scale, without adding detail, without adding explanation. The universe is not something you look at. It is something you are inside of. This statement now carries no metaphor. You are embedded in a structure where distance is delay, where observation is memory, where location is time-shifted, and where scale changes what rules even mean. This is not overwhelming anymore, because nothing is being asked of intuition that it cannot support. We do not imagine the universe. We do not compress it. We do not try to finish it. We let it remain large. This is the stability we were building toward. Throughout this descent, we did not replace intuition with wonder or fear. We replaced it with constraint. Every step followed from the last because it had to. When distance grew, waiting appeared. When waiting appeared, simultaneity failed. When simultaneity failed, location softened. When location softened, size lost containment. When size failed, time became local. When time fractured, evolution became structural. When structure deepened, unseen components dominated. When dominance shifted, hierarchy dissolved. When hierarchy dissolved, law became contextual. When law shifted, intuition had to be retrained. Nothing here was optional. This chain did not lead to mystery. It led to clarity without simplification. Now we sit inside that clarity. The night sky has not changed. The universe has not changed. Only the expectation that it should feel intuitive has been removed. We do not feel small in this frame because size is no longer a value. We do not feel lost because location was never absolute. We do not feel behind because now was never universal. We are simply present locally, temporarily, and precisely. This is not philosophy. It is alignment with structure. There are things we will never see. There are moments we will never observe. There are regions we will never influence. These are not gaps in understanding. They are consequences of scale. Understanding does not mean access to everything. It means knowing why access is limited. And that understanding is complete in the only sense that matters. It does not break when scale increases. The universe does not end at the edge of observation. It does not center on any location. It does not move toward narrative closure. It continues. Expansion continues. Structure continues to evolve. Information continues to be delayed and lost beyond horizons. None of this requires interpretation. It is simply the reality we inhabit. We began tonight by implying that something familiar was misunderstood, not because people failed to learn enough, but because intuition was asked to operate far outside its range. That intuition has now been replaced, not erased, not dismissed, but retrained. You no longer expect the universe to fit inside a picture. You no longer expect scale to behave gently. You no longer expect completion. You expect consistency. This is the reality we live in. We understand it better now, and the work continues.